Welcome to Star Pencil, Basic Understanding Concepts. Today we will learn about roots or zeros of the polynomial equations. In the last class, we discussed about the one example, okay, that's total number of students in the classroom you have taken as 100 numbers, okay. So that's I am rewriting that equation again. Total number of students in the classroom we have taken as 100 numbers, okay. So here we do not know the how many number of boys in the classroom and how many number of girls in the classroom, okay. So we have assumed that whichever we do not know, we will assign a variable to it, okay. For example, I am taking a variable for the number of boys x, okay. X is the variable I assign to the number of boys. Similarly, number of girls I am assigning another variable called the y, okay. So we know that total number of students in the classroom is 100. So from the above two, we can write the expression x plus y is equal to 100. So this one we see in the last class. Okay, now I want to tell you something different here, okay. Here, if you know the x, y you can find from the equation, but x and y cannot be the independent numbers. For example, if it is x is 30 independently and y cannot be independently like 30, 40 or something, it need to be satisfied this equation. Y must be equal to 70 to satisfy the equation, so that 30 plus 70 is the 100 is the equation. So already I said in the last class that we have 10 classrooms, okay. So each class has the 100 numbers students, but here some of your classmates or some of your principal will be revealing the number of boys in each classroom, so that we need to find out the number of girls in each classroom. But from this expression, okay, this expression called, or this equation we know, okay, this equation we know. From this equation we can find out the number of girls, okay. But what the inputs we get independently, that we are calling the independent variable, which are the dependent in the other variable, right, that is called the dependent variable, okay. For example, see, I will write the same expression here like this: x plus y is equal to 100, okay. So your headmaster is always giving input as a independently for all the classrooms, right, x they will be giving. For example, class 1 30 number of boys, class 2 40 number of guys, like that he is giving the input, okay. We need to find out the number of girls. Then what right, we will keep one side y and we will send the x to the other side. When sending to other side, it will change its direction, minus x plus 100, right. So in this expression, right, what you will call, so we are getting randomly for the all the class the inputs x number, okay. That's why this x we are calling independent variable and this y we are calling dependent variable, because it's depending on the number of girls, okay. It cannot be any number, okay. But suppose your principal is giving inputs always as a number of girls, but we need to find the number of boys. That time we need to write the x is this side and y is other side. Then the dependent and independent variable will be interchanged, okay. So I am rewriting this expression here again. You see here, y is equal to minus x plus 100, okay. So y is the number of girls, x is the number of boys. So what is the power in this equation? Max is the 1, okay. Then what you will call, this is called the first order polynomial equation or linear equation we will be calling, okay. So I am writing again here one more thing. Y is equal, it's a function of x, right? It is always, it's by varying the x only, it's changing the expression. So we are calling the function of x, that is equal to minus x plus 100. Okay, so y can be expressed as the function of x, and that expression is the linear equation or the first order equation, that's minus x plus 100. Okay, from this equation we can find the number of girls for the each number of boys number given as our input. Okay, so let's take, we have the 10 classrooms I said, right? For example, in the class 1 we have number of boys is 0. Okay, that means x is equal to 0. Okay, then if you put x is equal to 0 into the above expression, we get y as 100 numbers. Okay, and similarly in the class 2, let's take x is equal to 10 numbers, 10 boys, then y is 90. Similarly, if I write in class 3, let's take the number of boys is 20 numbers. Okay, then number of girls are 80. Okay, for example, in class 4, okay, number of boys is 50 and the number of girls are 50. Okay, so how do you get the number of girls? Here is 100, so in the above expression we will substitute 0, okay, plus 100, so we get the 100. Similarly, y is equal to, you substitute the x is the 10 is the number here, so minus 10 plus 100, then you get 90 as the number. Similarly, y is equal to, if you substitute x as 20 here, minus 20 plus 100 is 80 numbers. Okay, so number of girls here is, if you substitute 50 minus 50 plus 100, it's a 50. Okay, now we will represent all these data points into the graphical format. Okay, so let's take a graph. So x-axis is the number of boys and y-axis is the number of girls we have taken. So y is again function of the x we know. Okay, so that's where I will represent here, y is equal to function of x, that means p of x, that's equal to minus x plus 100. Okay, now we will draw the curve, okay, from the data points. Okay, what do you know? So I will keep giving the different x variable number to find out the y. Okay, so for example, x is equal to 0, so we know that this is x is equal to 0, x20, x40, x60, x80 numbers, x100 numbers, like that. Similarly, this is the negative axis. Similarly, here y is the number of girls is the positive axis. So 20 numbers, 40 numbers, 60 numbers and 80 numbers and 100 numbers. Okay, now what is the x is equal to 0, then y is, from the expression we get the 100 as the number. Okay, so they mark this point. Okay, y is the 100. Okay, this is the y is the 100 number. Okay, so similarly x is equal to 10. 10 means around here. What is the y is the number? Y is the 90. 90 means it's between the 80 and 100, there is a 90 point, so it comes around here. Okay, similarly, put x is equal to 20, y is equal to, x is equal to 20, y is the 80, this is the point. Okay, this is the point. I am not able to locate exactly. Let's take, this is the point. Okay, similarly, x is equal to 50 is the in between, then you get the y is equal to also 50. Okay, similarly, what is the x is equal to 100 then? Then y must be 0. because the total number will be always 100 from this expression, so that if it is x is equal to 100, y must be 0. Okay, that point is touching here. So if you draw a line, if you are joining all these points, okay, it must be a straight line. Okay, straight line. Okay, straight line means it requires only 2 points to join. Okay, so rest of the points automatically it come on that line. Okay, that line we are calling as a linear equation. Okay, it just requires the 2 points. Okay, so now we will see what is the zeros of the polynomials or roots of the polynomials. Whenever this polynomial equation becomes 0, that means y is equal to 0 or p of x is equal to 0, then for what value of the x p of x is equal to become 0 or y is equal to 0, right? That x number is calling the roots of the polynomial or zeros of the polynomials. Okay, now we see from the above expression. Okay, so y is equal to minus x plus 100. Okay, so for what value of the x this y will become 0, we need to find out. For that, so we will substitute y is equal to 0 here. Okay, 0 is equal to minus x plus 100. Okay, so that means if you take x is another side, so x is equal to 100. Yet x is equal to 100, y becomes the 0, right? So x is equal to 100, y becomes the 0. So then, x is 100 is the zeros of the polynomial or roots of the polynomial we will be calling. Okay, now you will see the more examples. Let us take another example. Okay, so I am writing another polynomial equation that's called the p of x is equal to 2x plus 3. Okay, so in this polynomial equation, usually we will represent in another axis this p of x, so that if you take it as a some y, okay, if you are taking y, so then it will become y is equal to 2x plus 3. Okay, y is the function of x. Okay, so what we will usually be calling, this is called the independent variable and this is called the dependent variable. So this y value depending on the x, okay, that's why we are calling this is a depending variable and x is the independent variable. So independently we will give this number. Okay, similarly we cannot give the all independent numbers to the both. Okay, that's why I remember. So one is become independent means another will become automatically depending variable. Okay, so we will represent this equation into the graphical manner. So let's take a graph. Okay, so now we have the graph. Okay, so here we will see we will just input the different x numbers, okay, to here to find out the y variable. Okay, for example we can find out any number of points. Okay, so I'll just give some of the x numbers. Okay, I am just writing what happens when x is equal to minus 2 and when x is equal to 2. Okay, so so from this we will find out the y. Okay, so when x is equal to minus 2, so we will substitute this x is equal to minus 2 into our basic equation. So that is y is equal to 2x plus 3. Okay, so if you substitute x plus minus 2 plus 3, then we have minus 4 plus 3, that's equal to minus 1. So we have one point. What is this point? X is equal to minus 2 comma y is equal to minus 1. Okay, so this point, or you can write it as the geometry minus 2 comma minus 1. So first is the x coordinate we will write, second is the y coordinate we will be writing. Similarly, when x is equal to plus 2, then y is equal to 2 into 2 plus 3. Okay. So we have 4 plus 3, that is 7. So we have another point where x is equal to 2 and then y is equal to 7. Okay. So we will mark these points into the graph. Okay. So let's take what is called when x is equal to 2, what is the y? Okay, y is a 7. Okay, mark this is the point, right? So mark this point, right? This is the point. Okay, then similarly when x is equal to minus 2, y is minus 1. So when x is equal to minus 2, y is equal to minus 1 2. So I said, right, these are the linear equations, right? Linear equations, 2 points is sufficient to draw a line. Okay, so all the variables which are you give x value, that much must be laid on this line. For example, we got the 2 points, right? I am just joining these 2 points in this straight line manner. Take the scale and just join between these 2 points. Okay, I am just drawing like this. So you can extend this here also like this. Just studying. Okay, this is a straight line. It's a single straight line I had drawn. Okay, here. Now if you keep giving the x variable here, we can find out the y. That all the points which must be lying on this line. Okay, that's why it's called the linear equation. Okay, we just require the only 2 points to get this line. Okay, now what is the zeros of the polynomials when y became the 0? Become 0, what is the x? Okay, that x we are calling the zeros of the polynomial or roots of the polynomial. Okay, so what we do here, we will make it the p of x is equal to 0, we will make it. Okay, then that means 2x plus 3 is equal to 0. That means 2x is equal to, we will take 3 as the other sides, that is become minus 3, and x is equal to minus 3 by 2. So what is the point here? Y is the 0 and x is minus 3 by 2. Okay. So 3 by 2 comma 0 is the data point. So where the y becomes the 0, so minus 3 by 2 is called the, x is equal to minus 3 by 2 is called the 0 of the polynomial equation or roots of the polynomial. Okay. So we will mark this minus 3 by 2 into the x-axis. You can see here clearly what is 3 by 2 is approximately it is minus 1.5, right? Minus 3 by 2 means it's 1.5, right? Almost. So it is you can see here straight line already it cut it minus 1.5. Okay, you can see here this is got, it is lying on the, always lying on the x-axis, because where the y will become 0 is wherever the line touches into the x-axis, right? X-axis, right? That number, right? Y will be always 0. Okay. So this is the point we are calling minus 3 by 2. This is the point. Okay, it's called minus 3 by 2. In this class we will learn about zeros of the polynomials for the linear equations. Okay, next class we will learn about zeros of the polynomials for the quadratic equation and cubic equations. Okay, thank you.